We didn't have a lot of issues on part A, but I'll solve it anyway. So part A says find the derivative of y is equal to 2x squared over 2x plus 1. So our u is equal to 2x squared, and then our v is equal to 2x plus 1. So as you can see, since we are dividing, we apply the quotient rule. So we can differentiate this to get du dx. This will be 4x. Then we can differentiate this to get dv dx. This will simply be a 2. And then by the product rule, the quotient rule, remember to start with a v and end with a v. So it's v du dx minus, remember it's minus again, not plus. Quotient or division goes with minus, and then multiplication or product goes with plus. So every time you are dealing with the quotient rule, remember to put a minus here. So minus u dv dx, and then everything over v squared. So you start with a v and end with a v. You can't swap the u and the v. That can only be done when you are dealing with the product rule, where it doesn't matter which one is being added first. But for subtraction, it matters. 9 minus 4 is not the same as 4 minus 9. These two are not the same. But when you are adding, yes, that's true. Whether you say 9 minus 4 or 4 plus 9, the answer will still be the same. So now our v is 2x plus 1, and then our du dx is 4x minus our u is 2x squared, and then our dv dx is 2, then everything over v, which is 2x plus 1 squared. This times this will be 8x squared, and then this times this will be 4x, and this times this will be 4x squared, everything over 2x plus 1 squared. Then these two are like terms, so you can say we have 4x squared over, plus 4x over 2x plus 1 squared. Some of you were factoring out the 4x there, which was okay, but this is enough. And then secondly, we have this part here, finding the equation of the normal. So what you need to know about the normal is it is perpendicular to the tangent. So find the equation of the normal to the curve, this. So the gradient of this at this point is the negative reciprocal of the gradient of the normal. It's like saying find the equation of the line which is perpendicular to this line at that point. So we can start by finding the gradient. So to find the gradient, this is calculus. You can start by finding dy dx. So this one will be 4x minus 3x squared. So now you want to find the gradient when x is equal to -1. This is given by 4, where there is x, put your -1, minus 3, where there is x, put your -1 again. Of course, this one is squared. So this will be -4. And then -1 squared is 1 times -3. This will be -3. Then this minus this will be -7. So now, this is the gradient of the tangent. So if this curve was like this, and then this point was here, then this would be the gradient at this point. The normal is perpendicular to the tangent line. So the gradient of the normal will be the negative reciprocal of this. So you can either do it like this: m1 multiplied by m2 is equal to -1, or you can simply say m2 is equal to, you get the reciprocal of that and then you negate it. Since it was a negative, it will be a positive. So let's use this one for the sake of the marker. So we have m1 as -7 multiplied by this, which is equal to -1. So you divide both sides by -7, you have your m2 as 1/7. So now to find the equation, you already have the gradient as 1/7, and then in the equation we have a point, this one here, which is -1, 3. So to find the equation of the line with these properties, it's passing through this point and has this gradient, you can simply use my favorite method, the gradient method, x minus x2, x1. If you want, you can still put your 2's there, but you don't need them. So this one will be 1/7 is equal to, you write your y, then your y1 will be a 3, then x1 is x is x, x1 is -1, then you can cross multiply to find the equation. So I'll start with this so that I have my y on the left hand side. This times this is 21, then that times that, nothing will change since that's just the 1. Then you can take the -21 to the other side. So this one will be this, 21 will be positive. So the equation is x minus, actually this was supposed to be a plus because we have a minus there, my bad. So plus 22, like this. You can either leave it like this or you can leave it in standard form by dividing through by 7. So I've just divided everything by 7 to obtain this. So this is your answer.